Let me start that again. Hello, everybody. Welcome to this week's Exo Life Hangout. My name is Tony Darnell. I'm from deepastronomy.com, and we have got another great hangout planned for you today on Exo Life and the life on, I should say we got another topic of Exo Life that we're going to be talking about, which is von Neumann probes and exploring the galaxy, the Milky Way galaxy. And we've got some really great guests here today to talk with you about some papers they had written and some they've been thinking about these things. And I've been thinking about them for a long time too. So as I started to say, I find myself every Wednesday looking forward to these hangouts because I learned so much from them, first of all, and the topics are just amazingly interesting. So I want to let you guys know that I am monitoring all these different social media things. We're on YouTube as well as Twitch, Facebook, and Periscope. It was Facebook that was the culprit on that. It popped up and started playing in my browser, and I should have had that window closed. So my apologies for that echo there. Okay, so let's go ahead and get. I also wanted to mention that these hangouts are a collaboration between deepastronomy.com and the Planets Foundation. And the Planets Foundation is a group, we've talked about them a lot. We're in part holding these hangouts to kind of raise awareness for what the Planets Foundation is doing, and they're building various telescopes. And we talked about one of their more interesting ones last week with the Colossus telescope that they're going to be building as well. But and so as a means of introduction, let me introduce one of the members of the Planets Foundation. He is my co-host. He's here roughly almost every week with us. This is Dr. Jeff Kuhn. Hi, Jeff.
Hi, Tony.
Hi, welcome back. I'm glad you could make it. Now, the other co-host we usually have is Dr. Svetlana Berdugina, but she couldn't make it because she's on travel this week. But Jeff is with us. How you doing, Jeff?
Good.
All right.
I'm in Honolulu. We're celebrating the 50th anniversary of the Institute for Astronomy, around 50 years.
The 50th of what? The Institute for Astronomy?
The Institute for Astronomy in Hawaii.
Oh, nice. That 50 years, really? Wow, that's awesome.
Yeah.
Okay, well, cool. Well, welcome, and also is also from the Planets Foundation is Kevin Lewis. He's going to be driving the internet. Hi, Kevin. It's good to see you.
Hey, hello.
Good. So he'll be helping me drive the internet. He'll be also looking at a lot of these chat windows and reading your questions out as we go along. So we hope you guys will participate with us on these various windows. Okay, so let's go ahead and get started. Let me introduce our guest today. My first guest, and I'm just going to go from right to left on my little hangout window here. First up, we have Dr. Martin Barlow. He's from the University of British Columbia. He's a professor of math there. Hi, Martin. Welcome.
Hello.
And you were at the University of Wales a while back too, right?
A long time ago, I did a PhD there.
Well, welcome. Yep. I'm glad to have you here on a hangout. It's good to see you, and interested to hear what you have to say about some of these topics. Also with me is Keith Wiley. He is an author, and he is. Let me put up the right lower third. He is an author at keithwiley.com. He has written his latest book. One of his latest books is about uploading your mind, or mind uploading. And he's also wrote a paper in 2011 where he discussed this exact topic that we're going to be going over, the idea of exploring the galaxy with von Neumann probes. So welcome, Keith. It's good to have you here.
Hello. Thank you for having me.
Great. Okay. Well, let's go ahead. Let me. As an additional reading material, if you want to follow along, I put links in the description boxes of YouTube and Facebook, not necessarily Twitch because I couldn't do it before it started. But if you want to read the papers that our guests have written, Martin's paper as well as Keith's paper is available on link. So I would encourage you to download it and read it. These are papers they had written back in Keith's paper was in 2011, and Martin, when was your paper written?
It was 2011, 2012.
Okay,
it
so
appeared in
about the same time.
2013.
Okay, good.
Yeah.
All right, good. Well, okay, so I would like to start, I think, with you, Martin. Can you give us, well, maybe, actually, I want to just talk about the issue of the probes themselves. What are von Neumann probes, and who wants to give us a little background into what those are? And I'll let either one, Martin or Keith. Who wants to go?
Keith, I got...
Sorry.
Okay.
Let's see. So the basic idea behind von Neumann probes was the realization that evolving the evolving technology of artificial intelligence would eventually lead to exploratory space probes with the capacity to actually create new versions of themselves from raw materials. Obviously, this is not something we're capable of now, but it's sort of this expectation that that sort of technology would become feasible. And if you could create, the kinds of space exploration probes that we have already created, but with the sufficiently advanced technology to create copies of themselves, then you could explore a galaxy or any area much more efficiently, because you don't have to create everything, where it starts. The financial and material cost is offloaded to the entire to the mission. So basically, these probes go out into the galaxy, and whenever they arrive in a new stellar system, they land on a planet. They find the sufficient raw materials to make new copies of themselves, and they do this multiplicatively. They don't just make one copy. So you get this kind of exponential sort of spread across the galaxy. And that's the basic idea of it. And then, where people take that is to consider, how would you sort of mathematically estimate how long it would actually take to sort of reach most of the interesting places in the galaxy, and what would be the implications then for our expectations, what we think we should observe when we look around us.
Right, and the scale of the problem here, folks, is pretty big. We've got the galaxy has hundreds of billions, well, I think now that was like we're on order of 2 trillion stars, they're saying, are in the Milky Way galaxy. On average, if you just did the average, and this was in a paper that we talked about from Jim Annis a while back ago, there's about a star every light year, but of course that's an average. Some stars in the outer part of the galaxy are much further away than the ones in the inner part of the galaxy. So in order to colonize the galaxy or even travel the galaxy, the distances there are very difficult. And as Keith was pointing out, these probes are one idea that we can use to maybe do this in a reasonable amount of time. But as Fermi put up with his we postulated with his paradox, he said that, well, the galaxy is old enough, and there's been plenty of time for civilizations to develop, and perhaps develop some of these technologies to explore the universe, or to explore the galaxy. And if that's the case, then where is everybody? Why don't we see any evidence of that? And one sort of straightforward way to do this kind of exploration would be with these kinds of probes. You build a self-replicating probe, a probe that when you launch it, it goes out to a star or a system, uses the raw materials there, makes another probe that then goes out and goes from there, and then it just sort of exponentially grows. And hopefully the thinking goes that this could be done in a reasonable amount of time. Martin, do you want to maybe comment on that part of it a little bit? This idea of what Fermi said versus the scale of the problem of actually getting to these stars?
Fermi said, where are they? And so what we realized with the concept of von Neumann probes and exploring the galaxy in this way is that unless you're extremely pessimistic about future technology, this is the sort of thing which is feasible in a period of 10 to 20 million years. So if we can explore the galaxy in 10 to 20 million years, so could any other technological species. If they exist, some of them could have been around for billions of years before us. Where are they? And, as a partly result of writing this paper, I actually had a kind of conversion experience. I used to believe in aliens. I really liked science fiction with aliens. And as I was writing the paper, I began to think, well, maybe they don't exist. It's the simplest solution to what we see.
It takes a long time, doesn't it, for these probes to get around and to get to various.
Sure.
And so, yeah, we're going to touch about that in a little bit. Now, Kevin, you said that the paper links I just put in went away when I went live.
Yeah, I think so. It's back to the old description. So I did post new links in our Hangout window, so they should be there if you want to.
Okay. And can you post them on the chat?
I can post them in the chat.
Yeah, because I'm having trouble reaching the chat for some reason, so I'm going to be relying on you also to see the chat window for me. Yeah, so I have the Twitch chat, but not the YouTube chat. So apparently the links went away when I went live. That's because I didn't put them in the right place before I started. But Kevin's going to put them in. They are on, however, I do see them here on the Facebook post. So if you're on Facebook watching this, the links are all still intact. So check them out there as well. And I'm also looking at Facebook since I can't see YouTube. So, okay. So in those papers, that I had, I put in a couple of links to some really old ones, and the ones that I had actually ran some simulations. These were made in 2007 and 2008 by some guys who said, what if one guy actually, and his name was just R. Bjork is all I have here. But the name of his paper is Exploring the Galaxy Using Space Probes. And his simulation started with just 4 or 8 conventional probes. These weren't von Neumann probes, okay? These were not self-replicating. They were just regular probes that went out into the galaxy. And basically, he found that if you just started with 8 or with 4 probes, it would take way too long. It would take like 2% the age of the universe to explore about 4% of the galaxy, because these probes there would be 4 probes that went out, and then once it got to the nearest star, they would launch 8 more or 4 more conventional probes. And they depending on how many probes you started with, it still took on order of about 300 million years to explore the 10,000 nearest star systems of 40,000 each. I'm just quoting from the paper here. So again, these are just conventional probes. However, if you use self-replicating probes, then that time was cut way down to about 4 million years to about 300 million years, depending on the search criteria and a lot of the initial assumptions. So these von Neumann probes can cut down the amount of time that we can visit these probes with, or that we can visit these various star systems with. But I don't really know how. And so maybe go ahead, Keith.
Well, I mean, if you think about it, it's sort of obvious where the secret sauce is in here. If you're not going to use self-replication, then your probe, or to say you're going to use 4 probes, is hardly any different. You're basically saying that your probe is going to take a tour of the galaxy. Well, the galaxy is pretty big. To take a tour of the galaxy, for any one spaceship to sort of follow a meandering path and hit every point in the galaxy is obviously, totally absurd. That's going to take a long time. It's a galaxy. What the self-replicating probe angle on the whole thing by is you said any one probe doesn't have to do that. You're painting the galaxy, in a replicating way, so that it's almost so intuitive. I don't really quite know how to explain it. You're just sort of spreading across it very analogously to the way bacteria spread across a petri dish, frankly. Any one bacteria, as small as it is, trying to move across a petri dish that is 3 inches across is a gargantuan task. But if they spread across replicatively, it's a completely different problem, and it's literally exponentially easier, which is why the numbers just fall away.
I'm sorry. Go ahead, Martin.
Okay, so in my paper, I assume that we can get the probes to travel at 1% of the speed of light. And I mean, I think there is a possible pitfall in thinking about these probes. We can imagine them to be a little bit like bacteria, which somehow, you have a probe and then a moment or a bit later, you've got 2 probes. If we think about how we might build those probes, I think it's more realistic to think of the system where a probe arrives in a star system, builds a factory. The factory then produces lots of probes.
I agree.
And it might take a long time for the factory.
Where would the factory be? At one of the star systems that have a lot of resources?
So
every
time.
You go into a star system. I don't know if it's better to choose as your place an asteroid, a comet, some free floating space, the surface of a suitably light planet. But you build the factory there, and maybe it takes 1,000 years to build the factory. But even so, that doesn't slow down your exploration front. So in my paper, you can do a quick calculation. You have the time taken to build the factory, you have the time speed to go across the galaxy. Even if half the time is spent building factories, your exploration front moves at 1/200th of the speed of light. and you've crossed the galaxy in 10 to 20 million years. And
yeah, I'm sorry. I completely agree. I think we can basically we can simplify the speed question by thinking of sort of the total average speed, as you just said, sort of at the end. It's not how long does it take to fly there, and then how long does it take to make a factory. It's what is your average sort of rate as you proceed through the galaxy. And you're right. It's hard to sort of knock it down by a large amount by saying it would take forever to build the factory. Also, it's would it really? I mean, are we overly handicapping ourselves by saying it would take 1,000 years or even 10 years? This thing lands on the equivalent of a moon, and it obviously is advanced and has these sort of nanotechnological capabilities. I think that it would be able to make copies of itself from raw materials in a reasonable period of time. I think we can think on the scale of years as opposed to millennia.
But it doesn't make much difference, does it?
You're right. It doesn't matter one way or the other. And because you spend so much time in space, what difference does it make how long you're in the system?
I mean, so I like to be pessimistic about our future technology in the sense that conservative. If we're conservative, we still have a big problem with the Fermi Paradox. If we assume wonderful technology, near speed light, replication in years rather than thousands of years, that just makes the problem worse. But the problem is still exists. Agreed.
The other interesting thing that SRPs, self-replicating probes, just for brevity, bring to the question is, again, when Fermi said, where are they? What people often think of is sort of SETI-like projects where you're scanning the sky for radio frequencies. And, there's always the question of whether we're just kind of like, we're not seeing the signal or something. And, the variable that SRPs bring is they really strengthen the question of where are they, as in, why aren't they here? One thing that I calculate at the beginning of my paper is sort of the lower and upper limits on how many SRPs ought to be in our own solar system. and I can't, with the most conservative estimates, I can't get it below 100. And the upper limits would be in the billions. And this is just sort of using kind of a Drake-like equation where you sort of, estimate how many species there are and how many, what the replication rate is. And it's hard to push that number down so low that there wouldn't be numerous such instances in our own galaxy. And this is why I think the SRP question just really exacerbates the Fermi paradox.
Right, because I mean, if that were if we can do it, and we could kind of do this now, couldn't we, guys, with the technology that we have now?
Self-replicating technology is totally out of our reach.
Okay, maybe it's the other probes where the standard, maybe a conventional probe might be able to go out, hatch 4 to 8 more conventional probes, but that we couldn't do the self-replicating thing.
No, we do not know how to make either hardware or software. Well, software to some extent. Chris Langton and other people in the artificial life community have done some work in software. But to make a hardware system make a copy of itself can't be done in 2017. But I don't think that we're more than, 100 years away. I mean, we're on the cusp of this technology. Even if it took us another 1,000 years, that really has no impact on sort of the larger discussion we're having about galactic exploration here.
I know, and that's sort of the problem, is that we really got to look at the long term of this stuff, because you're not going to get it in the next election cycle. For example, this has to really be something we think about for the long term. So what would we be doing? I mean, all right, so in your most optimistic projections, first of all, let me ask you, do you guys think this is one of the best ways to colonize the galaxy, or not colonize, just explore the galaxy, or are there other better ways?
It's by far the best.
By far the best. Okay, and
that I know of anyway.
Okay, so Martin, in your best projections, when you launch these self-replicating probes, how many do you start with?
Well, as Tipler pointed out in one of his early papers, you don't need to start out with very many. One is in principle enough. But if you make one, you probably should make 20 or 30, something like that. And so to kickstart the system, you send those 20 or 30 probes to, the 20 or 30 nearest stars with some sort of planetary system and some sort of enough stuff there that you can use them for replication. Then the second generation in my view, these probes then build factories. Once you've got the factories, and you've got a little cluster, your first cluster of colonies, as we'll call them, 20 or 30 of them, those then send out thousands of probes for the second generation, because you've got the curvature of the area explored is small. As the exploration goes on, you get more and more flat curvature in the region explored, and a star now only needs to send out maybe a few probes in order to sort of build out the next layer. So that's how I see it going.
Plus, once you get out about 1,000 light years, it becomes a two-dimensional problem. You're now traveling across the galaxy. You're not really expanding out three-dimensionally. So the dimensionality shifts dramatically once you sort of expand to the thickness of the galaxy.
But that's, well, okay. Okay, so let's talk about that a little bit. So in the outer regions, do you go more in the third dimension than you do closer in?
Well,
does it matter?
Yeah, first of all, I would say it doesn't matter in that I try not to speculate too much on what I think aliens would do. What I try to do is leave open the possibility that sort of anything that is achievable and could have a reasonable mission objective to any given sort of psychological temperament, whatever given species or culture is inclined to do, they may design a probe mission within those parameters. So, again, given the tremendous diversity that we would have to assume that, alien species would have, pretty much any sort of mission you can imagine that has a practical application should be expected to be sort of in progress out there somewhere. It's not a question whether there's one mission that doesn't make sense. The question is, why do we see nothing at all when the basic concept seems so sound?
I know. We're looking. Well, let's talk about the nature of what these probes would do when they got there. So we launch them. They go out. Would they just be flying by and taking a look to see if anything's there? I mean, that would be the most time efficient way to explore a system, right? You just fly through it to see if anything's there. That'd be pretty hard for us to detect, I would think.
But then you can't do any replication. You've got to land and build and harvest physical materials. I mean, a flyby mission doesn't satisfy the self-replication.
But not every system that you go to is going to have enough raw materials to do anything with. So you may just move on.
It could be lots of dead ends.
Right.
You could send out 100 probes and maybe only 1% of them actually reaches a system where it can manage to self-replicate again.
And so your point is that since we live in a system where we have quite a bit of raw materials, any self-replicating probes coming from somewhere else would probably want to set up a factory here, and we should see that.
Well, so again, we're sort of assuming human sort of curiosities. So if the goal is to find all the interesting intelligent species out there, then you would do flybys of all the numerous solar systems that don't have anything. But if you came into our solar system and you had that sort of human motivation to find all the other intelligent species, and once you find Earth, this is an interesting place. You're not going to do a flyby and vanish off into space. Why would you travel halfway across the galaxy just to fly by Earth at the 10th speed of light?
Well, because you want to set a marker. You want to say, you want to just look at all the. It's like what Kepler does with exoplanets. Kepler looks at one spot in the sky, measures these candidate planets, these candidate light curves, where they said there might be an exoplanet here. We need to follow up and with better telescopes and more observations. So maybe that's what they're doing. Maybe they're just flying by and go boom. That's pretty promising.
Let me reemphasize a point that I bring up a lot in Fermi Paradox. No, it's okay. We need to make sure we don't make assumptions that would apply to all of them. Maybe this species over here sends out a mission that does a flyby, and we don't see them because they fly through the solar system at a tenth the speed of light, and they're gone before we blink. But how can that assumption apply to every species? Maybe the ones that are out there that would want to land here, landed here, but we don't see them. That's the interesting question.
So that's a really interesting question, right? Because the analogy there is to an ant that wanders into the city. Do they know that they're in a city?
You're very difficult to hear, Jeff. There you go.
I've been jumping at the bit here because
go for it.
The notion that because we should see many of these and that we haven't is kind of assuming that we haven't seen them. And my sense of that is, if I were an ant living on the surface of the earth and I wandered into a city, would I know that I was surrounded by super intelligent beings? Would I even recognize that fact? Now, on the question of whether we're close to being able to build self-replicating probes. We can do that now, and it's called synthetic biology. So there is, in my opinion, the best example of a self-replicating probe isn't the Arthur C. Clarke 2001 Space Odyssey obelisk, cyanobacteria or water bears or some sort of maybe 10 to the 5 base pair basic organism, which we, by the way, verified that we could take life not so different than we know it, encapsulate it, keep it away from the UV, shoot it out into the universe and survive. The diffusion time for traveling between the stars by natural phenomena, I think the Kuiper belt or the Oort cloud of comet-like objects, those are traveling at a large fraction of the mean separation between the stars. So it really isn't hard, I think, to imagine, first off, that I agree with you, the exponential process here that we're all describing is hard to beat. But the conclusion that they're not here, and therefore there isn't life outside of the universe, I think is mitigated by the fact that we don't really know that. And again, it's the ant and the human being analogy. Would an ant recognize us?
Well,
yeah. Then it's just this other point that the best self-replicating probes that you can make, which I can imagine making, is essentially life. Life is self-replicating. It's incredibly efficient at being able to move and adapt to the environment, which is unknown. And if I wanted to fill the universe with, I mean, this is the Kurt Vonnegut idea. Remember his short story years ago? I don't remember the name of it, but he was going to explore the universe by collecting the collective sperm of millions of men and just shooting it out into the universe. It doesn't work biologically. But the idea that the self-replicating probes are maybe us or maybe biological organisms that have adopted in ways we don't know, I think is not something that we can disprove.
Okay, did you going to comment on that further, Keith?
You
could hear him?
There were a lot of interesting things there to respond to. I think that you made. I mostly agree with everything you said. Let me jump in on one sort of detail actually, which is that you made a reference to whether we're speculating on life in the galaxy or life in the universe. I don't know if you misspoke or if you were just generalizing, but I make no claim about the universe at large because this argument does not apply between galaxies. In the age of the universe, we can't make the SRP assumption that the universe is empty on the same argument that we're presenting relative to the galaxy. Is my point coming across?
Yeah, and I guess I say life in the universe because in the same way that you've been saying, we can't assume what the motivations of all these different life civilizations might be. My feeling is that if it works here in the Milky Way, there's nothing totally special about this. What should work here, it should just as well work in IC 1101 or whatever, some other kind of galaxy.
Well, my point is that.
That's why I say
no. I'm sorry. My point is that if there were intelligent life in another galaxy, we shouldn't assume that their probes or their exploratory programs would have reached us.
Agreed. And I guess you and I agree. I'm just I'm using universe and galaxy a little bit interchangeably, and I should probably be a little more careful and just say galaxy. But I figure what works here would probably work elsewhere. Can I get Martin? I want to talk about the numbers a little bit. You're a mathematician. And so here we go. We've got billions, trillions of stars in the Milky Way galaxy. Now, we've learned since your paper was written, since Keith's paper was written, and since the papers I read were written, that there are, on average now, 1.6 exoplanets, or 1.6 planets around every star in our galaxy. Now, that's an average. Not every star has 1.6. Some have no planets. Some have 10 or 12 planets. But on average, that means there's more planets in our galaxy than there are stars. Now, as a mathematician, and as you've been thinking about von Neumann probes and life in the galaxy, what does that do for you? Does that make you feel like, oh yes, of course, there must be life in the universe, and of course there must be civilizations out there. The numbers are just too great. Or do you think something else?
Well, the number of civilizations in the galaxy is the product of two numbers. One is the number of stars in the galaxy, or the number of planets in the galaxy, which is huge. And the other number is the proportion of those planets which produce a civilization. And that number is completely unknown for us. We just at the moment have no idea what the chance actually of life forming on a planet is, or if the life forms, does it remain in primitive, is it primitive life almost certainly, as Bromley and Law would suggest? Even if complex life forms, what's the chance of intelligence? Some evolutionary biologists say the chance of intelligence is very, very small. I don't completely follow their arguments, but of course that's also guesswork. So we're multiplying a very big number by a number which we have just no idea about at all.
We're just guessing.
Unfortunately, math doesn't help you much. You multiply, 10 to the 13, which is the number of planets, by x, where you don't know x, and you don't know what the answer is.
Okay, so
I agree.
We just don't have enough information is the answer to my question. I was trying to get you to go out on a limb and say, yeah, of course there's planets everywhere, or life everywhere.
So, one of the things about the idea of exploring the galaxy by these probes is it gives us, not us, but, our descendants in a few thousand years, we'd actually perhaps begin to get an idea of what's going on in the solar system. So as I see it, the probes arrive in a system, they build a factory, they explore the system, they build telescopes to look at nearby systems to see which of the systems have got planets and favorable for sending stuff to, and they beam the results back to the place where the probe came from, which ultimately means the stuff comes back to us. So if we send out the sort of system that I'm thinking of, the Earth is the node of a huge information network of information from all over the galaxy coming into us, telling us about potentially every star system in the galaxy. We don't get that information for 20 million years, but ultimately we could know about everything in the galaxy, every single star system.
Well,
every single planet.
Well, that's a good point, and I want to go. I'm just going to go ahead and read Cosmic Stardust's comment or question here from the chat. By the way, the YouTube chat is really wonky today. I have to keep unpopping it out and popping it out so I can see it. But she is asking, or he is asking, I'm sorry, I'm not sure which one, Cosmic Stardust. Are the purpose of these probes to transmit information back to us on Earth, or to spread out bits and pieces of interstellar embryo style? I'm not sure I understand exactly what these probes are. And I think you just said, Martin, that we're looking to get this information transmitted back eventually.
Well, maybe.
The probes that I'm envisaging are to get information back to us.
Exploratory probes, yes.
Yes, exploration. Of course, once we've got the system of factories all over the galaxy, then maybe we can do other things with that. Maybe we can get them terraforming planets, preparing them for whatever our successors or humans look like in 20 million years. But initially, the aim is exploration.
Okay.
I agree that we definitely. I'm sorry. Did you want to go?
No, go ahead.
I do agree. The first pass at sort of imagining what these are is to imagine them as extensions of the probes we sent around our solar system. So, sort of robots for the purpose of informing the really important brains and minds, the humans back on Earth, about letting them learn remotely about their solar system. There is another take on this. There is the notion, there's this whole sort of question of biological exploration. This was alluded to a little earlier in the discussion, whether we would send out, sort of, I don't know, DNA samples, or whether we would just sort of start creating these kind of generational ships and things like that. I personally don't put a lot of stock in biological interstellar travel because this gets into an area where people hold strong opinions. But there is the possibility that our technology evolving through the 21st century seems to be pointed in a direction where a lot of the critical aspects of what makes sort of humans really living, conscious, thinking creatures might be sort of reducible to mechanical principles, which we can then essentially sort of remove the biological limitations from, move it into more technological substrates of some sort. And there's a lot of buzz terms that float around this, whether people are interested in singularity or not, whether they're extraterrestrials and transhumanism or not. I personally am not a big fan of terms and buzzwords, but there is the question of whether we are going to get to the point where sort of the notion of what we are becomes increasingly technological. And if that happens, then it completely changes the nature of the self-replicating probe question and its mission, because it's not just some remote, dumb probe for capturing camera images and sending them home. It becomes the wavefront of a colonizing mission where a species or a culture is not sending probes out, it's sending itself out pilgrim style to settle across the galaxy. And, I completely understand that, in 2017, a lot of people just aren't on board with the idea of computerized intelligence. And I realize it's a leap at this point. It's an extrapolated leap. It's not a wild leap. It's an extrapolation of what our science and technology is doing. But, I really think that we should give some credence to the idea that what we're really talking about here isn't just exploratory probes. We're talking about the most meaningful way in which a species would colonize a galaxy, which is by first, dispensing with biological limitations, and then by doing the galactic exploration in a much more feasible way, using engineered technologies which are robust to interstellar mediums and time frames and everything. And that I think that's a completely different take on it, but a take that we should take seriously.
And is that something? I'm going to let you comment here in just a second, Jeff. I just want to say I only just found out about your book today. But is this the one that do you address some of these issues in your book? I'm going to give your book a plug because it's really cool. It's called The Taxonomy and Metaphysics of Mind Uploading. Is that something you kind of get into a little bit with your book?
Yeah. Well, the book is mostly metaphysical philosophy. It's not a really strong engineering book. It's more about it's investigating what the nature of the mind actually is. But yes, it's all the same larger discussion sort of around the edges. The book doesn't really talk about space exploration. It just gets into the.
Well, I guess it's insofar as getting rid of the biological component of some of this stuff.
Yeah,
that's where I was heading with that.
Yeah, so. It's all basically asking sort of David Chalmers kinds of questions about what is it that is or is not sort of reducible to biology and can be otherwise moved into more robust substrates is definitely what my book is kind of getting at.
All right, great. Jeff, you want to comment?
Yeah, so the idea that the probes that might be launched by some future civilization or us in some number of years are reconnoitering the universe is probably mitigated by the fact that we will soon, certainly within 100 years, be able to recover most of that information by remote sensing. If the energy barriers of doing anything with the information, if we live in corporeal bodies, when's the singularity? 42 years from now? If we were to...
I thought it already happened. Sorry.
Biological beings, we're not going to... The energy requirements for transporting and bringing natural resources or using these faraway worlds in any way that we can imagine now is really hard to imagine. On the other hand, if there was a civilization that went through a phase like ours and lasted maybe 1,000 years or more longer than us, I see these probes as essentially the grass that we plant around our house. We're happily ensconced in a very pleasant place. We don't want the weeds to encroach upon us or to come up and choke out whatever happiness exists in our own little houses. If I was an advanced civilization and I knew that my existence evolved spontaneously out of something on a planet, I might be concerned that not of the substance would evolve somewhere else, and therefore I would plant grass. I would surround my house.
Okay, in your analogy, Jeff, the grass is the probes, and the weeds are what?
Oh, the grass is something benign, right? Here we are. We're happily living in one corner of the universe, and we realize that evolution produced other civilizations, perhaps less benign than us, somewhere else in the universe. So I'd like to plant grass to displace the weeds. right? So the probes are always, in my estimation, the best self-replicating probe for biology. We send them out into the universe, and they become the grass that protects the civilization that exists somewhere else, in some other corner, right? That's because this idea of seeking information about the universe is much better done with electromagnetic radiation and the kind of telescopes that we'll have in a few years. So I don't see them as probes. I see them as colonization, but it could be little copies of us, but who knows what the message is that contains. Or it could be the benign grass that prevents the development of a species that will really come in and do something not so friendly.
Okay.
There are actually practical limits on even the theoretical resolution of telescopes. I mean, if we want to see the atmospheres or even to some extent the surfaces of nearby planets, I agree that we seem to be getting there. But if we wanted to know about the nature of planets that were halfway across the galaxy, we can't just build a bigger telescope. We have to go there, take a look, and send the data back.
Yeah, and supposing we want to know about the biology of creatures in a moon of a planet circling Alpha Centauri in a sea, how is a telescope ever going to tell us that?
Well, it's called rotational inversion, and I can send you to a paper that does it. But the point isn't the details of the resolution. The point is, what good is that information anyway? For a planet which is 100,000 light years away from us, the energy barrier to actually using or making or taking advantage of that is enormous. And furthermore, the time element in when we get that information to where we are now means that it's old news, right? It's like reading papers from 10 years ago and trying to make sense of it and use it for our benefit.
I agree completely, which is why I generally am more interested in colonization scenarios than exploration for exactly that reason. By the time you get any of the data back, it sort of doesn't mean anything on human timescales.
Well, I mean, Martin was saying earlier that we're looking at, what, 20 million years? Is that what you said, Martin? Or it was like, we might learn about this way after the fact. So now I'm getting confused. Now you guys are talking about colonizing with these probes as opposed to just reconnaissance, right? You guys are saying that this would be more of a colonization effort, depending on the nature of the probes. But I'm
open to all possibilities.
Yeah, why not? I guess. But let's talk a little bit about what kind of intelligence would these probes need to have. We're looking at they need to know how to reproduce themselves. They need to know how to go out in a reasonable plan to explore the galaxy you don't want to just be dumb about it and go like straight out of the plane of the sky. So they need to know, or the plane of the galaxy, they need to know where they're going. And then they kind of need to know what to do if things go wrong, right? I mean, these have to be pretty sophisticated. We have to be, what if...
The self-repair mechanism to survive an interstellar trip is itself, an intelligence-bounded problem. Just to keep a ship put together cannot be done with simple algorithms. So when you were self-monitoring.
When you were saying, Keith, earlier, we don't have in 2017 the ability to do this. This is where, to my mind, where the real rubber meets the road. This is the hard part, right? Getting this programming, this intelligence, this ability to do this job in a way that works.
Yes, we cannot create this kind of technology yet. Not even close. But to say not even close doesn't mean we couldn't do it in 1,000 years or even in 200 years. So again, on the scale that we're talking about exploring the galaxy, it's sort of, to be frank, it's kind of irrelevant. But it's true that we can't do it right now. So we have to allow ourselves to sort of visualize where our technology is going to get to.
Are we worried at all, guys, about this thing just sort of deciding that it wants to just kind of go into business for itself?
Oh, definitely. That's one of the classic worries about this thing. So that's why I think that one should try and make these probes as stupid as possible, given the difficult tasks that they've got to do. And we don't understand machine intelligence very well. Particularly, we don't understand what kind of intelligence is much more sophisticated computers than our present ones might have. But what you don't want to do is that some probe mining some star halfway across the galaxy suddenly starts asking itself questions like, why am I doing this for these humans after running past the galaxy? We don't want it to have that capacity. So, as I say, you want them, in my view, you want them stupid. Or you want to limit the directions of their intelligence. You want them to be able to build telescopes, look at stars, say, does this star have planets? You want them to be able to look at asteroids, say, does this asteroid have the materials I need for my factory? You don't want them thinking deep philosophical questions about me, about my purpose.
Right. So, which I don't know how you would do, but okay. So that's one issue. So back to, what is it with the chat today, Kevin? This is like a real mess. So
yeah, I'm not.
I have to keep getting in and out of chat. So, let's see. Patrick Festa is commenting, "Hello, Tony. A fan of yours. I'm not a fan of the Fermi Paradox. I have ideas that I couldn't summarize in a text chat." So let me get you guys' thought on this. I mean, what are your opinions on Fermi's Paradox? I mean, Keith, you alluded to some of it before when you said that we can't be presumptuous about what to expect. What's your response to Fermi? Where is everybody? I'll start with you, Martin. Okay. Go ahead, Martin.
Okay, as I said, my views really changed as I was writing my paper. I used to think that maybe something like the zoo hypothesis, they're out there in the outer solar system watching us, was a possibility. But I just find myself thinking that's extremely implausible. Interesting to hear what other people think about the zoo hypothesis. And my view is really the simplest explanation of why we don't see them is because they're not there. And the Russian scientist Kardashev talked about, K1, K2, K3 civilizations. K3 civilization has the energy of a galaxy. We look out there, as far as I can see, we don't see any signs of K2, K3 civilizations. My program was for exploring the galaxy, but maybe if civilizations were common on other galaxies, you'd see K2 stars, K3 galaxies. We don't seem to. Again, the simplest explanation is we don't see them because they're not there.
Keith?
Yeah, I essentially agree. I think that aside from the self-replicating probe sort of take on things, my response to almost any optimistic solution to the Fermi Paradox, an optimistic one being where they do exist, but there's some good reason for it, most of those solutions fail what's called the non-exclusivity problem, meaning that it would have to apply to every single species, every single colony, every single mission to explore the galaxy. The zoo hypothesis is a perfect example of the sort of complete violation of the non-exclusivity problem. If you have 1,000 species out there, 1,000 of them have to apply the zoo hypothesis to basically choose to sequester Earth. If 999 of them do that, but one of them wants to talk to us, then the zoo hypothesis is totally, it's just hopeless to explain the paradox. And this seems to work. This sort of logical failure applies to most Fermi Paradox solutions. It's very hard to come up with one where there are a whole lot of them out there, but there's a reason that applies to all of them. And what the SRP sort of variable brings in is it just makes the problem vastly harder, because it's not just a question of whether we would see them out in the sky, in sort of stars that look like they have Dyson spheres, and or whether they're emitting radio, optical beacons. The problem becomes much harder when you calculate even the most conservative estimate of how many of them should have flown into our solar system, or when you calculate the rate of flux at which they ought to be arriving. The most conservative estimate you can come up with is about 1 a century. I mean, 20 of them should have arrived just since we gained, just since Rome, basically. It's just the problem with a theory that sort of makes it easier to travel around the galaxy is that Fermi is then the Fermi paradox is confounded not just by seeing them way out there, but it really asks the question not only where are they, but why aren't they here?
Exactly. Yeah, that's what you said earlier.
So I understand that people want intelligence to be out there. It makes the galaxy, it makes the universe a more interesting place to visit. It makes the universe a more sort of
friendly.
It makes it satisfying to think that we're part of this big community, and someday we're going to meet them. And I understand that, but that's not a logical analysis. So the question is, can we really defend the theory that there must be lots of aliens out there in spite of this observational evidence? I'm having a hard time coming around to it.
I know.
I think they could be in other galaxies, but I just, our plunky little galaxy out of all the galaxies in the universe, I'm just saving our one galaxy for the one where I think they're unlikely. I think there can be trillions of intelligent species out there. I'm not a pessimist against intelligence in general. It's just that the travel times within the galaxy make it hard to defend within our galaxy.
Jeff, you want to comment on that? I know you got something to say about that. If you could speak close to your device, because your audio is really bad. So maybe speak slowly.
Can you hear me now?
Yeah, we can hear
Yes.
you. Yes.
So I think that the mistake that we make, and we've done it historically many times in science, is to think that we're special. We're at a special place in the solar system, we're at a special place in the galaxy, or we're at a special place in the universe. It's this desire to make humanity special. When we talk about communicating with life, we can't even communicate with any other species on our own planet.
Yeah, Neil Tyson,
Neil
deGrasse Tyson makes that point too. I'm sorry, go ahead.
And so how would so the other time scale that I think is important in understanding how to communicate with any other life, and there are actually two others that are important. One is that we cannot yet see if there's life on the nearest exoplanet. Within 10 or 15 years, we will be able to look for those biomarkers on Proxima b. The universe really has no information to give us empirically about whether there is life nearby or not. We just don't have the sensitivity, but we will soon. The other problem in our understanding of this meta problem is that our evolution is so fast. We're not going to be speaking the same language, and technology is a part of evolution. I think it's required that if any stage of biological advancement reaches a threshold, then the fusing of wet chemistry, biology, evolution with the things that we now think of as technology have to happen. Aliens, I think, period of time, a few hundred, maybe 1,000 or a few thousand years in our history, it is going to be almost unobservable. And everything that we've talked about when we talk about aliens kind of uses this window of vision, which is, I think, terribly limited. Either we won't exist in 100 years, or we'll be incredibly different, and if we're going to be.
Okay, so Jeff, are you saying then that the way we perceive the universe is limiting us, and that the way we are perceiving these aliens may be what keeps us from detecting them?
I think we keep thinking of aliens as little green men that might be traveling in spaceships, and in 100 years, the idea of a spaceship or transporting is going to go the wayside.
So cosmic stardust.
The other.
Oh, go ahead.
Sorry.
I just wanted to reiterate, because that was based on a comment from Cosmic Stardust, who says, "Is there anything to say about the possibility that aliens may exist, but outside of our perception?" And you're kind of talking about that.
Exactly. At this point, we cannot say that the universe and whether it has life, even in the nearest exoplanet, is a closed window to us. We don't have that sensitivity.
Absolutely. Sorry, go on.
No, it's just, I think the other time scale and the problem when we talk about the Fermi Paradox is what our perception of life looks like. I think it's colored by this fairly brief instant in time, me hoping that civilization and life goes on in some form, which is a somewhat restricted view of life in the bodies we have. The other point, which I make strongly, we can't tell what life looks like. If we look back just a few million years to earlier life forms on our own planet, we can't communicate. And now we're talking about an advanced life form and asking whether or not we're even there or they're even here, and whether we could communicate, I think is a really hard problem. And it makes
well, the question we can ask is whether we see things that don't look like they fall within our understanding of natural phenomena. If we look out at our solar system and it looks like a bunch of spherical rocks, it's a reasonable assumption that most of that stuff was built by gravity as opposed to intelligence. Maybe there's a bunch of spherical rocks out there because aliens arrived in the solar system and turned them into spheres, but we just rely on the natural explanation until we find something explicitly unnatural, and we're not seeing that.
I think there's a wise person that once said a sufficiently advanced civilization might look like magic.
Precisely.
But the corollary to a sufficiently advanced civilization will look like nature. And so and again, I keep coming back to the same analogy, ant versus human. We just don't have the tools or the mental capacity to compare the processing power that exists in an ant to that exists in a human. So I think part of what you say may in fact be true, but we don't know what we don't know.
I agree. And shouldn't we only speculate sort of at the level that we are capable of, instead of asking whether aliens exist on the defense that they are somehow invisible to us? Shouldn't we simply, at any given point in our own sort of scientific and technological understanding, should we speculate based on the sort of tools of scientific observation available to us at that date? So
I don't know. Ptolemy at the time speculated that we were at the center of the solar system, and he was probably told that we shouldn't go beyond the limits of the logic of the day. And luckily, we had Copernicus, and we did go beyond that. So I buy that.
So Jeff, go ahead.
Can
Martin.
I just?
You may go ahead, Martin.
Can I just make one comment? That
Sure.
if we have an advanced civilization and it does information processing, that uses energy. And I think that the second law of thermodynamics then means that you're going to get a lot of infrared radiation coming out from that civilization. So, I mean, one of the ideas that people have had for looking for aliens is look for stars with large infrared excesses. And these physical considerations make me a bit doubtful about they're just invisible to us kind of idea. If there are really smart aliens, they should be producing lots of infrared.
So it's all about energy, right? Energy and heat. And so I think the definition of life that we could agree on is that thermal energy is involved. And there have been a bunch of searches, astronomical, to look for objects that don't have a visible signature but have an infrared signature. And those searches go on. You're talking about, I think, a limit that we would like to experiment with right now. So there are proposals, from the Planets Foundation, to look for, in fact, the signature of life by looking for this heat signature. You don't have to be much more advanced to do that, and that might very well be universal. That's certainly something that I think all life should possess, even if it's just for the information processing. Although be aware that the most efficient information processing probably involves Boltzmann's constant and the information and the entropy associated with that. I mean, that's many orders of magnitude away from the technologies that we have now. Mm-hmm. So, I hear what you guys are saying, but I just feel like we do have analogies, biological analyses, and the Earth that suggest that, if we really were very good at communicating with other life forms, there would be at least one other life form on the Earth that we could communicate with, and the answer is we can't.
Well, I do think there's a common assumption that we're talking about life that is sort of has surpassed some sort of vague threshold and sort of linguistic capacity, and I don't think anyone does necessarily think that. I mean, people talk about sort of the language of dolphins and octopus and things like that, but in general, I think we're all sort of in vague agreement that that's not quite what we're talking about. You say that if we could talk to aliens, then we could talk to animals, but there actually isn't any other species on Earth that actually sort of quite meets the criteria we're all kind of talking about here. Do you disagree with that?
I agree with that. I think we assume that that that's the difference between us and dolphins. But there are plenty of people who say that reflects other biases that we have. But yeah, you're right. I can't prove what we don't know is of this sort of. I mean, I'm a firm believer that 100 years from now, life will be completely different here, and that this idea that we've integrated the information, all of the content of our lives and our thinking, into something that may not be it just seems like it's hard to escape.
Okay, well, I think we're going to have to leave it there. We are running out of time, but just real quick, Jeff. So you're optimistic then, from what you've been saying. These other.
I don't know if it's optimistic. I feel like life in the universe, and we're going to find it. And in this picture where the probes are biological, our corner of the universe got hit by this wall of colonization about the same time. Most of what's within our sphere of detection is probably at nearly the same level that we are. So I guess that's optimism. Yeah, our corner of the universe got hit by this wall.
Okay, all right. Well, I guess we're going to stop there, and I want to thank everybody for this. Was a great discussion. We were talking about the use of von Neumann probes, self-replicating probes, to colonize the galaxy, and to and whether or not what the advantages and disadvantages, and whether we could even do it. And we also discussed all of this in relation to Fermi's paradox. And I listened to Martin and to Keith, and I feel like these numbers are very, very depressing. But at the same time, I'm so glad I get to talk with Jeff on a weekly basis. So he keeps me in check and keeps me hopeful. So anyway, I want to thank all of you for joining. My guests today were Dr. Martin Barlow. He's a professor at the University of British Columbia at the Department of Mathematics there. Thank you, Martin, for joining us. It was a lot of fun.
Thank you. Thank you so much.
Also with me is the author, I'm not sure if you're a doctor, but it just says Keith Wiley.
I am.
You are? Okay, Dr. Keith Wiley. He is an author. He has written a really interesting book that's currently on Amazon now, a taxonomy and metaphysics of mind uploading. But he also wrote a paper in 2011 about these self-replicating probes, and the link to that will be in the description box as soon as this hangout is over. We had to repost them on the chat. I'm sorry about the problems with the chat, folks. I did see some of your messages, and Facebook and Twitch seemed to be working, but nobody was on it. The ones on YouTube were weird. So anyway, thanks for your patience, guys. Anyway, we will, just so you a little programming note, this is the next weekend, or next week is the 4th of July week here in the United States, and so I will be off. We will not be having a hangout next Wednesday, but we will be back in 2 weeks, right, Kevin?
Yes, absolutely. 2 weeks from now.
Okay. Do we know what the topic is yet?
We're still working on it. I want to maybe lunar colonization or the technium, which is a idea by Kevin Kelly. So either one of those two, hopefully.
All right, good. Well, so join us again back 2 weeks, folks, Wednesday, 7 p.m. Eastern time for these hangouts. Thank you all so much for joining. And on behalf of all of my guests, I want to thank you all for watching. And as always, keep looking up.